For a dynamic model to run and calculate properly, many inputs need to be formatted differently than they are in steady state. In addition, some items must be added to your model while others need to be removed. Ensure that all inlet and outlet streams connected to vessels with significant holdup are attached to valves, and that pieces of equipment that have significant holdup are separated by valves. If there will be holdup tanks in your process, install these before transitioning to dynamics, as they will affect your dynamic simulation results. Ensure that your equipment is sized properly, and finally, specify dynamic specs on the boundary streams of your process and pressure flow relations in unit operations that don't have significant holdup, like heaters. Make sure that any mixers are set to equalize all and not set outlet to lowest inlet. HYSYS Dynamics provides a dynamics assistant that can be used to check that everything is configured properly for dynamics. The dynamics assistant ensures that all units are rated, boundary streams are connected to resistance devices and have valid dynamic specs, that all unsupported unit operations are removed, and that degree of freedom requirements are met. It will also warn you if non-recommended specifications are encountered, such as a flow spec on a boundary stream, a fixed pressure drop in a resistance device, or specifications set for internal streams. The file that we will be working with has 5 boundary streams: Alpha, Bravo, Charlie, Hot VAP, and HP Lick. The upstream streams are connected to pipes, which are resistance devices, and Hot VAP is connected to a cooler, which is also a resistance device. But HP Lick is connected to a separator, which is a holdup device. We need to add a valve to this boundary stream. Let's use the Dynamics Assistant to make the necessary changes. Before doing that, though, let's look at the dynamic specifications on the boundary streams. Go to the Flowsheet Modify tab in the HYSYS ribbon. Open the drop-down next to Default Color Scheme and select Dynamic PF Specs. Blue means that a stream doesn't have any dynamic specifications set. Red means that both pressure and flow are set. Green and yellow mean that pressure and flow specs have been set, respectively, while gray is for energy streams. It looks like the specifications will have to change. We want the boundary streams to have pressure specs, while the internal streams should not have any dynamic specifications, but the Dynamics Assistant will be able to do it for us. Go to the Dynamics tab and click on the Dynamics Assistant button. The Dynamics Assistant has several suggestions. The first 3 are to correct stream dynamic specifications, and the 4th is to add a valve to HP Lick, because it's a boundary stream that's connected to a conductance device. I want a large pressure drop across the valve, so let's specify that. Double-click on the 4th item and specify a pressure drop of 550 psi. Then go back to the General tab. When specifying the pressure spec in a resistance unit, there are 2 options: fixed pressure drop and resistance to flow, K. Resistance to flow is more realistic, so you should pick that option. The next item in the list tells us that a unit has a fixed pressure drop specified. There's one more issue. A unit has an unknown volume. Double-clicking on it, we see that the high-pressure separator isn't rated. HYSYS suggests this size, but I actually want the volume to be 4,500 cubic feet. After specifying the volume, click Make Changes. Some of the changes that the Dynamics Assistant made are immediately visible. A new valve has been added to the HP Lick stream. All boundary streams are green, and all the internal streams are blue. Let's take a look at one of the boundary streams. Double-click on the Alpha stream and go to its Dynamics tab. This tab is used to set dynamic specifications, and we can see that a pressure specification is active, while the flow specification is inactive and is being ignored. Let's take a look at our cooler. HYSYS defaults some unit operations, for example, heaters, coolers, and heat exchangers, to a default value of 0.1 cubic meters. This is way too small for us, so go to the Cooler Dynamics tab and set a volume of 500 cubic feet. Now, let's check the sizing on our valves. HYSYS automatically sizes our valves, but we can change the sizing or the correlations used in sizing. Double-click on Valve 100 and go to the Rating tab. Select Manufacturer-Specific Methods and choose Universal Gas Sizing from the Valve Vapor Flow Models dropdown. We have a linear valve, so let's make sure that's selected in the Valve Operating Characteristics section of the form. At steady state, the valve should be 50% open, so enter that into the valve opening % field. Then select Size Valve. HYSYS will use the information we have input along with steady-state process conditions, like pressure drop and flow rate, to size the valve. Notice that CV and CG have been updated. Since we have selected to set CV, HYSYS sets CV, and C1, which is the ratio of CG to CV, is used to calculate CG. Let's also check the dynamic specifications for the valve. Go to the Dynamics tab and make sure that total delta P is unchecked, and pressure-flow relation, which is more realistic, is checked. Repeat this with the remaining valves, then save the case. The file is now ready to be converted to Dynamics. Always save before converting to Dynamics. Sometimes specs are changed when running in Dynamics. Go to the Dynamics tab in the HYSYS ribbon and click Dynamics Mode. If everything has been set correctly, it will ask you whether you want to convert. Click Yes, then click the Play button to run the integrator. After the integrator has run for a few seconds, stop it.